Okay, so let me start by introducing myself. I am Ahmed. I'm the Outreach and Training Coordinator for Fairmat. I'm very excited to be here today to present to you about NOMAD, our research data management platform for material science and solid state physics. So I will start without any delays on what is NOMAD. So whether you have used it before or not, I will go into basic steps into this talk. So NOMAD is a web-based software, which means that you can access it through your favorite web browser. And through that, you could access, explore, and upload your research data in a fair manner. If I would like to describe NOMAD in a single statement, I would say NOMAD is about sharing data, not files. And this is actually what sets NOMAD apart from traditional data repositories, is that your uploaded files get extracted in a structured manner where the data and the rich metadata becomes fair and searchable within our tool. And in NOMAD, you could explore and reuse millions of fair data from others. For example, if you go to NOMAD now through this link here, you will find more than 19 million uploaded data entries, and you could explore them, filter them, and without even creating an account, but you need to create an account if you would like to apply analysis or you upload your data. So from here, I would like to take you to the core functionalities of NOMAD. And the first core functionality is the ability to query the repository using various filters available, such as by element, material, or method. And this could be achieved by using our graphical user interface or programmatically. And I have a screenshot here to show you how this filtering works. And basically, you can see in the left column here all the available filters where you can filter data entries in NOMAD, such as the elements, the methods, and so on. Or you can pick your elements from the periodic table graphically here. And as you do so, the available entries that show on your screen will be filtered to show those that only matches your search criteria. And from here, then you can pick the entry that you would like to explore further and click on the arrow to its right. This takes you to the next core functionality of NOMAD, where you can access all the essential metadata and visualize the key input and output information in the overview page. And this is an example of one of these entries in the overview page here. So you can see in the left column all the relevant metadata to this entry, from the method name, the program used for this calculation, and the author, and so on. But also in the right column here, you'll find all the relevant input and output information in a nice visualized and easily readable tabular manner. And if you scroll down to this page, you would even see like the output band structure calculation and the density of states for this specific entry. You could also, from the overview page that I just shown, to go into details, into browsing the detailed metadata for each entry within the standardized structured schema, which I will talk about in more details later in this presentation. And for this, you move from the overview page to the data page, then you'll manage to browse the data in NOMAD in its hierarchical structure. As you can see, you click in the sections or the subsections you want to explore until you reach the quantities and read the values in there. And of course, if NOMAD offers data to explore, then there is a room to upload your research data as well. And this is the fourth core functionality I'm showing you today, where you can upload your research data by simple drag and drop of files. You can share them with your collaborators, and you can also publish them into data sets with DOIs. And for this, I show an example of a computation data file of a DFT calculation in Silicon. And this is basically a zipped file of the various output and input files that were used in this calculation. And if you simply drag and drop the file into NOMAD, NOMAD would match this file to the appropriate parser and start reading these files, populating the data schema, and then create entries of these data, as you can see in the screen here. And you can edit upload members by adding your colleagues or collaborators who are using NOMAD, and then you could assign them roles of a reviewer or as a co-author, and you can also apply further modifications such as modifying the or editing the metadata for all the entries, or adding an embargo period for the published data on NOMAD. In a similar manner that I showed before, you can also explore your own data entries that we just uploaded in this example. And similarly, in the overview page, you can see a visualization of this data with the different outputs, band structure, list of states, prelude zone, as well the workflow graph, which presents the various steps that were carried out to carry this calculation in a very interactive and simple manner. And then you could see the different you can see the different sections and structure of the data and different quantities by exploring this data into details. What NOMAD also offers, in addition to these four main core functionalities, is that it offers a faceted search apps where domain-specific data are grouped and visualized in an easy manner, which can be filtered and also narrowed down to perform your literature review in these domains. And for example, if you go to the Explore menu in NOMAD, you'll see many examples of these domain-specific search apps. And in this presentation, I will show a specific example from the Solar Cell app, which contains around 40,000 data entries. And if you go to the Solar Cell app, for example, you'll see the available filters shown in this left column here. And you can see the number of search results available now, 43,000, around 43,000 search results. Then we start by picking a filter on the periodic table of the element that we would like to see in the active material. And in this case, it's 10. And you can see that it interactively updates all the available filters in this dashboard, and also the available entries narrowed down to 1,200 search results. Then let's say we would like to filter and narrow down based on the electron transport layer, and we pick C60 here. You can see further narrowing down and further update of the dashboard. And for the available visualization here of efficiency and open circuit voltage, you can also modify the view using the graphical user interface by grouping the data sets, for example, by whole transport layers, and then you have the view that you desire. And afterwards, you could see all the entries that match these filters, and you can start exploring them and look into more details about their synthesis procedures or their like AQE spectra and so on. So what I've shown you like right now is the main functionalities of NOMAD plus the search apps. But I would like also to emphasize and highlight what are the key elements when you use NOMAD. So NOMAD has four key elements, namely the user, meaning you, the uploads, which a user creates. Then we have entries, which are basically the data that gets processed in NOMAD, and they are stored in the uploads. And finally, we have data sets, which are a subset of the entries that you created, which you would like to publish as a group and assign them a DOI. And if we just to show you how this all looks in our graphical user interface. So as the user, you log in and, you appear on the top here, then you go to the publish and create the uploads. And the uploads are basically dedicated directories or folders of your projects. And you can see in this screenshot here, I have 4 uploads of different projects. Some of them are only shared with me, so they are not public. One of them with this icon here, it's published on NOMAD, so any user in NOMAD could see it. But I have one upload where I only share it with a few collaborators. And then within each upload, if you go in, then you can drop files or add additional content to this upload. And the files that get processed by Nomad, that means it gets parsed and structured, it will create entries. As you can see, for example, here we have 3 entries in this upload. Uploads can also contain other files that are not processed by Nomad, and these you can view them by clicking on the File tab here. Then you can see all the contents available in your upload. The uploads which have like special name of a parser next to them, these are the entries. These are the structured data that are indexed in Nomad. And basically, this is how the uploads and entries are related in Nomad. And data sets, basically, if you want to create a data set from your entries, you just go to the edit metadata of all the entries and you create a data set. And then you start adding whatever entries you would like to publish with a DOI within this data set. And as it's created, you can see, for example, in this screenshot here, various data sets that I have. I have one example here that I have already assigned a DOI for. And if you click on this bookmark button next to the data set that was just created in the screenshot earlier, then you'll create a DOI right away that you can use in your publications. The key of all these aspects in Nomad is that Nomad structures the data. So it is built on structured data that is based on well-defined schema. And this schema in Nomad, it's called the Nomad meta info. And as represented in this schematic here, so the schema identifies the hierarchical structure of all the data that goes into Nomad. And then the data gets into Nomad either through uploading files, which gets parsed, and then it follows the schema and gets structured, or you could have the data come from your electronic notebook, and like as you fill it directly, and then it follows this template in the schema and structures the data in the structured manner in Nomad. And what's powerful about the Nomad meta info is that it's extendable. So it can be extended continuously to include other standards, such as, for example, we have recently adopted the Nexus data schema and also the VOC4CAT taxonomy, and it's implemented within the Nomad meta info so that data following these structures could be uploaded to Nomad. And once the data are in this hierarchical structured manner, it can be called also programmatically by APIs such as the Nomad API or Optimade, which is an API specifically made for material science repositories. The structured approach of Nomad allows integration of all different data sources. So whether you have a raw data file from instruments or an Excel sheet where you have pre-processed the data or modified some quantities in there, or you are manually entering data into your ELN, they could get into Nomad either by drag and drop or the direct input forms within Nomad, and then these data files, along with the schema and the metadata, would form the hierarchical structured data in Nomad, which enables which enables the data to be FAIR compliant and as well as AI ready, where the various machine learning models and data analysis approach could be applied directly within Nomad. The Nomad data structure fundamentals, I'm just giving a brief overview here for you to understand how this works. And basically, as I mentioned already, it's already organized in a hierarchical structured way. I will show a screenshot of how it looks in the next slide. When the data is processed in Nomad, when you create data entries, then it instantiates a common top-level sections or subsections from the meta info. So these sections, you can think about them as a table in a spreadsheet where you define the different columns with certain names and certain types. And then each of these columns basically represents one quantity included in this section definition. In addition to these common top-level sections that are matching full or nomad data entries, depending on the processed data, Nomad would instantiate and call specific subsections that could accommodate the data of the uploaded file. And then once this is defined, Nomad would start mapping the quantities from the data files to match the specific quantity fields in these subsections and form these structured data. And to get this more visual, so this is how it looks like in Nomad. So Nomad structures data and the hierarchical manner of sections, subsections, and quantities. So this is an example of one entry, and you can see like this is the main section. It contains various subsections, and if you click further, you would see, other subsections or quantities until you end up with a quantity and the value that fills up that quantities. And the common sections for all Nomad entries, like whether you upload a DFT calculation or electron energy loss spectroscopy data or PV data, you would see the main entry section includes the various subsections shown here. Regardless of the entry, they will always contain a results section and a metadata section, which define the basic or the main sections in Nomad that enable searchability and findability of the data. Sorry. However, for the specificity of the data uploaded, you would find different sections or subsections called to be more suited for your data. For example, for DFT data, you would find the run section or the workflow section. In the case of EELs, you'll find measurement section. For BV data, you'll find a data section. And if we go into details of this, like domain-specific sections, for example, for the BV data, you would see, like if you click at the data, that it's a specific section called perovskite solar cell. It has all the subsections that define the characteristic of this data coming from this domain, and then picking a random subsections here, you'll find the quantities that are used to define the different characteristics. And also you can see the values filled into these quantities. So moving on from explaining the fundamentals of Nomad, I would like also to give some attention to our key product. Like usually we say Nomad comes in two flavors, the central Nomad, which I explained, and you can access in your web browser, but also Nomad Oasis, which is a local management tool that basically gets installed in universities or research laboratories using your own resources, and you decide where to share the data with whom, and you even can define what kind of data supported in your Oasis could be. And in principle, we have several Nomad Oasis around Europe, the US, and also in the Middle East, more than 60 actually. And in each of these Oasis, you have the user decides the customization that they have in their installation. And this is enabled by the use of Nomad plugins, which I would like to introduce in my next slide. So the Nomad plugins are basically add-ons to the Nomad installation, which extends the functionality of the basic Nomad and achieves modularity, and also allows you to easily update your Oasis installation. You can think of a Nomad plugin as a small independent project that you create to define a specific data structure or a specific visualization tool into your Nomad Oasis. And in fact, the various entry points into the Nomad plugins that are available are shown in this slide here, where, for example, you could create a schema package that defines the structure of the data produced from your lab. You could create a plugin for a parser that reads the files that follow this data schema. You can create a search, a faceted search app as the examples I've shown, but specifically for your lab. All this is possible with the Nomad plugins mechanism that could be installed directly into Nomad Oasis installations. All this, what I've shown you, is being developed by Fairmat. And I decided to introduce Fairmat at the end to put more emphasis on the products that we are providing. So Fairmat is the National Forschungs Dateninfrastructure Consortium to build a federated data infrastructure for solid-state physics. We function into 7 task areas. The 3 topical ones are the synthesis, experiment, and computation, which cover the various formats and the structures of the data that a material scientist or solid-state physicist deals with. The infrastructure area, which ensures that NOMAD runs and the resources that we need are available to run all of our developments. The use cases area basically uses all the available developments from the other areas to create example demonstrators in specific domains such as batteries, solar cells, or magnetic materials, the training and outreach area, and finally the coordination and scientific administration area. And what Fairmat aims to achieve is to achieve a federated data infrastructure using what I've shown you throughout this slide. So by having several NOMAD oases installed all over the world, they're doing their own business, they're running their own data structures and doing the research data management practices in their labs. They could be interconnected to the central NOMAD installation that's installed here in Germany, where the data is also being stored at the MPCDF in Garching. The data could be transferred partially or locally to NOMAD so that it becomes available to the wider community through what's known as the Fairmat portal. If you would like to get started with using the central NOMAD and the various functions that I've shown you today, I invite you to join our tutorial later this month on 26th of February. The registration link could be accessed on the QR code here. This tutorial will focus on the first steps data scientists need to start using NOMAD, and it's all based on using the web-based version that's available on our website. So please join us if you would like to learn more. I also invite you to find us in these various venues in this year. So the most recently coming one is the DPG Spring Meeting. We will be there with a booth, a tutorial, various talks, and two co-organized symposium. We will be at the AMRS Spring Meeting as well as the Psyche Conference in Austin, Switzerland. Also, to get in touch with our developers, if you're already using NOMAD Oasis and developing your plugins, or just getting started, or have any questions about research data management, on Discord, you could find us almost 24/7. We use this channel for our internal communications, so you will always find someone to address your questions. You can join us by clicking on the QR code on this, scanning the QR code on this slide. I'll also share the slides after this meeting, so you can click these links. And with this, I would like to thank you for your attention, and I'll be very happy to answer any questions you may have. Thank you.